Hello, everyone. Today we're continuing on with our shapes by talking about rhombuses or rhombi or the shape that looks like this. So a rhombus is just another special quadrilateral. So everything that has applied about parallelograms applies to a rhombus. But a rhombus has four congruent sides. These theorems kind of define some different properties about rhombuses. So if a quadrilateral is a rhombus, then it's a parallelogram. So everything that was true about parallelograms are also true about rhombuses. If a parallelogram is a rhombus, then its diagonals are perpendicular. So remember what's true about a parallelogram is that the diagonals of a parallelogram split in half. So you can say that these two sides are going to be congruent because it's a parallelogram, but also the angles in the middle are going to be right angles because the diagonals of a rhombus are perpendicular. Finally, rhombus's diagonals bisect the angles. So notice what's happening. They create opposite angles. So look at all that becomes congruent because it is a rhombus. The diagonals will bisect the angles perfectly. Other theorems are the opposite. So how do we prove that something is a rhombus? So if one pair of consecutive sides of a parallelogram are congruent, it's a rhombus. So if we know the sides are parallel and then we know two of the sides are congruent, then we know it is a rhombus. Next, if we know the diagonals of a parallelogram are perpendicular, then we know it's rhombus. And finally, if we know that the diagonal in the middle of a parallelogram bisects the angles, then we know it's a rhombus. Notice that for all of these, we have to know it's a parallelogram first before we can apply these and say that it's a rhombus.